There is a plane flying right now, somewhere above you, that never needs to land to do its job. It carries enough fuel to fuel over 200 family cars. It can keep a fighter jet in the air for hours longer than it was ever designed to fly. Without it, some of the most powerful aircraft in the world would never make it to their targets. It has been flying for nearly 70 years, and most Americans have never heard its name. This is the KC-135 Stratotanker, the flying gas station of the U.S. Air Force. Introduction. Today we are going to break down one of the most important, most underappreciated aircraft in the entire history of American air power. Not a fighter, not a bomber, but without this plane, neither of those could do what they do. The KC-135 Stratotanker has been quietly working behind the scenes since the late 1950s. It has fueled missions in Vietnam, the Gulf War, Iraq, Afghanistan, and dozens of operations most people never even heard about. Every single time an American fighter pilot pushed deep into enemy territory, there was a very good chance a KC-135 crew made that possible. This machine is the backbone of U.S. air power, and today you are going to understand exactly why. If you are proud of what the men and women of the U.S. Air Force do every single day, type "God bless our airmen" in the comments below. Let them know we see them. Segment 1. The problem that created this plane. To understand why the KC-135 exists, you have to go back to the early days of the Cold War. It is the early 1950s. The United States is locked in a stare-down with the Soviet Union. Both sides have nuclear weapons. Both sides have bombers. And the U.S. military is staring at a very uncomfortable problem. American bombers, massive, powerful planes, could carry nuclear weapons, but they could not fly all the way to the Soviet Union and back without running out of fuel. The distances were just too great. You had aircraft that could end a war, but they could not reach their targets. The solution the Air Force came up with was not to build bigger planes. It was to build a plane that could feed fuel to other planes while both were flying through the air at hundreds of miles per hour. Think about that for a second. Two aircraft flying at over 500 miles per hour, thousands of feet above the earth, and one is pumping fuel into the other like a gas station hose. That is not science fiction. That was the idea, and the U.S. Air Force made it real. The original tanker in service at the time was the KC-97. It worked, but it had a serious problem. It was a propeller-driven aircraft. The jet bombers it was supposed to refuel flew much faster and much higher. So the bombers had to slow way down and drop in altitude just to take on fuel, which burned extra fuel and made the whole process awkward and dangerous. The Air Force needed a jet-powered tanker, something that could fly at the same speed and altitude as the jets it was feeding. Boeing had an answer. Segment 2. Birth of the Stratotanker. In the mid-1950s, Boeing was developing what would eventually become the commercial Boeing 707 passenger jet. But alongside that project, they were also quietly building a military version, a leaner, purpose-built aircraft designed to carry massive amounts of fuel and transfer it to other planes in flight. That aircraft made its first flight on August 31st, 1956. The U.S. Air Force took delivery of its first KC-135A in June of 1957. Within a few years, Boeing had built over 800 of them. Now here is something interesting. Most people assume the KC-135 is just a military version of the 707. That is actually a little backwards. Both aircraft came from the same Boeing prototype, called the 367-80. But the KC-135 was built to tougher military standards. It has a narrower fuselage, a stronger frame, and it was specifically engineered for the brutal demands of aerial refueling operations. The Air Force did not just want a truck in the sky. They wanted a machine that could take punishment, fly in all weather, and keep performing decade after decade. Boeing delivered exactly that. Before we go any further, please take a second to like this video and subscribe to the channel. It costs you nothing, but it makes a huge difference to us. Hit that subscribe button right now, and let's keep going. Segment 3. How does the flying gas station actually work? Okay, so you have this massive jet flying at 30,000 feet. How does it actually get fuel into another aircraft? The answer is something called the flying boom. Picture a rigid metal pipe about 28 feet long attached to the tail end of the KC-135. That pipe can move up and down, left and right, guided by a trained crew member called a boom operator. The boom operator lays flat on their stomach at the very back of the aircraft, face down, looking through a small window at the aircraft below them. They have two small wing-like fins on the boom they use to steer it. The pilot of the receiving aircraft, a fighter jet, a bomber, a reconnaissance plane, pulls up carefully behind the tanker. They fly in formation, holding a position just below and behind the KC-135, within arm's reach. The boom operator then guides that metal pipe right into a small receptacle on the top of the receiving aircraft's fuselage. When the connection locks in, fuel starts flowing. The KC-135 can pump fuel at a rate of around 1,000 gallons per minute. Now let us be real clear about what is happening here. Two aircraft are flying at over 500 miles per hour, in close formation, often in rough weather, at night, with turbulence and wind pushing them around, and one of them is threading a metal pipe into a small opening in the other. The boom operator and the receiving pilot have to work as one unit. One wrong move, and it is catastrophic. These are some of the most skilled aviators and crew members in the world, and they do this every single day. For aircraft that are not set up for the boom, like U.S. Navy jets and many Allied aircraft, the KC-135 also carries a different system, a flexible hose with a cone-shaped basket at the end, called a probe and drogue system. The receiving aircraft has a probe that pokes into the basket. Same idea, different connection. Some versions of the KC-135 can refuel two aircraft at the same time using pods mounted on the wingtips, one on each side, while also running the boom. 3 aircraft connected and fueling at the same time. Flying at 30,000 feet. Segment 4. What does this plane actually carry? Let us talk numbers, because they tell a powerful story. The KC-135 carries up to 200,000 pounds of fuel. That is around 30,000 gallons. To put that in terms most of us can picture, that is enough fuel to fuel roughly 250 standard family cars. Sitting in your driveway, that would be a line of cars stretching down your entire street. When it is not being used as a tanker, the KC-135 doubles as a transport. It can carry 83,000 pounds of cargo, or up to 80 passengers, on a deck above the fuel tanks. The U.S. Air Force has used it to move troops, equipment, and medical patients in and out of combat zones. The aircraft itself flies at 530 miles per hour. Its service ceiling is 50,000 feet. Its range on a ferry flight, meaning flying empty with no fuel to give away, is over 11,000 miles. That is almost halfway around the world without stopping. And the crew? 3 people. A pilot, a co-pilot, and the boom operator. 3 people operating what is essentially a flying fuel depot in the most demanding conditions on Earth. Segment 5. Combat proven, decade after decade. The KC-135 has not just sat on runways looking impressive. It has been in the fight for nearly 7 decades. During the Vietnam War, KC-135 crews flew thousands of missions, keeping U.S. strike aircraft fueled and in the fight over North Vietnam. Without those tanker crews, many of those missions simply would not have happened. Pilots who came home from those missions know exactly who to thank. During Operation Desert Storm in 1991, aerial refueling became more critical than ever. U.S. and coalition aircraft were flying long missions over Iraq and Kuwait, pushing deep into heavily defended airspace. KC-135 crews flew around the clock, day and night, making sure those aircraft always had the fuel to complete their missions and get home safely. The same story repeated in the years after. Operation Enduring Freedom in Afghanistan. Operation Iraqi Freedom. Strikes against terrorist targets across the Middle East and North Africa. In almost every single one of those operations, somewhere in the sky above, there was a KC-135 crew making it possible. There is a saying among military aviators: fighters get the glory, but tankers make the mission. The men and women who fly and crew these aircraft rarely make the headlines, but ask any combat pilot who has ever been running low on fuel over hostile territory, and they will tell you the most beautiful sight in the world is a KC-135 showing up right when you need it. And here is something that does not get talked about enough. Tanker crews are not sitting back in a safe zone. When they are flying close to a combat area, they are just as exposed. They do not have missiles or guns. They rely on speed, altitude, and the protection of U.S. air power around them. Those crews show up anyway, every single time. Segment 6. Upgrades that kept it flying. Here is one of the most remarkable things about the KC-135. The aircraft that entered service in 1957 is not the same aircraft flying today. Not even close. The Air Force has put this plane through multiple complete overhauls over the decades, essentially rebuilding it from the inside out while keeping the proven airframe intact. The biggest change came with the engines. The original KC-135A ran on older turbojet engines that were loud, fuel-hungry, and by modern standards, very inefficient. Starting in the 1980s, the Air Force began fitting the fleet with modern CFM56 turbofan engines, the same family used on many commercial airliners today. The results were dramatic. The upgraded version, known as the KC-135R, offloads 50% more fuel than the original, burns 25% less fuel itself, costs 25% less to operate, and is 96% quieter. Then came the cockpit. The Block 45 upgrade replaced old analog dials and gauges with a modern glass cockpit, digital displays, GPS navigation, digital autopilot, and updated communication systems. The crew went from 4 down to 3. What you have today is a 1950s airframe carrying modern engines with up-to-date avionics, and it works. Segment 7. The fleet today and what comes next. As of 2025, roughly 396 KC-135s are still flying across active duty units, the Air National Guard, and the Air Force Reserve. The retirement of the KC-10 extender in 2024 made this aircraft even more critical to daily U.S. Air Force operations. The Boeing KC-46 Pegasus is the intended replacement, with around 110 currently in service and more on order. But delays and technical issues have slowed the handover. The longer-term answer is the next-generation aerial refueling system, NGAS, still in development and not expected to arrive until the mid-2030s. The KC-135 is currently planned to fly until 2050. That would put it at nearly 100 years in service, something no other military support aircraft has ever come close to achieving. In 2026, the Air Force confirmed the brand new B-21 Raider stealth bomber completed its first aerial refueling test with a KC-135, the most advanced bomber in the world, being fueled by a plane born in the 1950s. That says everything. Conclusion. The KC-135 does not chase glory. It never has. It just shows up, does the job, and makes sure the aircraft that protect this country always have what they need to get home. Nearly 70 years. Nearly 400 still flying. And the mission is not over yet. That is the flying gas station of the U.S. Air Force. And now you know exactly why it matters. If this video added something to your day, hit that like button and subscribe. We have a lot more coming. We will see you in the next one.